we will see together how to graph the feasible solutions for a linear programming problem in Python. There are some things that you need to do before you actually write the program. You need to find the solutions of the equations, the system of equations, in order to identify what are the corners of the polygon that is shaded. On the right, you see the solution in Excel. You have the objective function z equals to 10x plus 10y. The constraints are 5x plus 8y greater or equal to 200, 25x minus 10y greater or equal to 250, x plus y is greater or equal to 150, x is greater or equal to 0, y is greater or equal to 0. Okay, the graph as it shows in Excel is this, and what we want is to shade the area in between the lines. Let's see how we can do that in Python. The first thing that you need to do is to import the matplot library and import all the functions from the library. Then import the numpy library and import the arrange function that it will help us to set up our graph. The first thing that we do is to actually define the figure, the file that we will save the graph. X is equal arrange negative 100, 200, 10. These let us define to the system between what numbers the x will run. It will be between negative 100 and 200, and on the graph we were going to show a step of 10, so in between we are going to increase by 10 on our graph. The y is the same arrangement from negative 100 to 200 with step of 10. At the next step, we define what is y1. So basically what we need to do is to take this equation here and solve it for y. Once we have it for y, then we show here to the system, we store the 150 minus x to y1, where the x moves from negative 100 to 200. We do the same for y2, the second constraint that we have, and we do the same for y3, the third constraint. The next step is to set up the limits on our actual graph in the figure that are going to be between negative 100 and 200. This is going to tell us that the graph, the actual graph, it will be a grid, the Cartesian plane, that it goes from negative 100 to 200 for the x's and from negative 100 to 200 for the y's. So it will be a 300 by 300 units on the graph. The horizontal lines, H lines, basically defines that the horizontal line is going to run from negative 100 to 200 and will have color black. The vertical line is the same, this is the y-axis, from negative 100 to 200 and will be colored black. Grid is true. This means that the intermediate lines of the Cartesian plane will show on our graph, so it will be a grid. If it's false, then it will be blank. The next step is to define the labels for the axis. So under the axis, the x-axis, we will write x-axis, and next to the y-axis we'll write y-axis with the y label. And then we are ready to plot the lines. So in order to plot the lines, we use the function plot. Always at the beginning you put the x, what is your x, the y1 for the first line that we want to graph, and the color of the line will be blue, B. We do the same for the second line that we have defined as y2 here, and this will be colored red, and the third line will be magenta. So now we have plotted the three lines. The title of the graph will be objective function z equals to 10x plus 10y with the following constraints. You don't need to write down the constraints on the title since you are able to add them in the legend. So we are going to put the legend to include each one of the inequalities. that correspond to each one of the lines that will separate the feasible region from the rest of the graph. So we have the three different lines here. We could also include the x greater or equal to 0 and y greater or equal to 0, but these are the axes, so we don't. And then we are ready to, then we have graphed all the different lines, and these, they meet and they create a polygon. This polygon, we need to know the corners of the polygon. We need to know the coordinates of the points of the corners of the polygon. This is necessary in order to let the system know where he is going to paint, what is the polygon that will paint with a specific color inside. In our case right here is the shaded area, as you can see it, and it has four corners, is a quadrangle. The one is 0, 150, the other is here 150, 0. The next point is here 50, 0, and the next point is here but doesn't show very well, is 0, 25 actually. This point is defined by three lines, the y-axis, the orange line, and the gray line, that they represent the two constraints. They give us the same. As I said before, in order to find those points, the corners of the polygon, you need to solve the system of equations. Like, for example, here you need to know at what point the green line crosses the y-axis, at what point it crosses here the x-axis, at what point the orange line, the constraint for the orange line, that is the line for one of the constraints, crosses the x-axis, and at what point here the orange line also crosses the x-axis. We do that and we find the following by hand, and we find the following numbers. The numbers that you set up for the x, it has four arguments, and it has four arguments because we have four corners. If we have 5, 6 corners, then we will have 6 arguments. And the x will be defined by the different coordinates, the x coordinates of the points. Then we define the y, again the y coordinates of the points. Make sure that you write them in the same order, because this means that 0, 0 and 25, 0 is the first argument for both x and y, and this means that we have the point 0, 25, and then we have the point 40, 0, and then we have the point 150, 0, and the last point is the 0, 150. Once we do that, we know exactly where we want to paint, and we use the function fill that is going to paint in between those points. X are the coordinates, the x coordinates of the points, y are the y coordinates of the points, and we are going to paint it red there. And the last one says that we are ready now to show the graph, basically to graph everything on a file. So we are ready to run this, and once we do, we are getting our graph. The objective function is the title. You see here the legend and the lines. The blue line is the first constraint, the red line and the purple line are the two other constraints. And as you can see, we have filled in between those lines, and this is the feasible region for this maximization problem.